whatever we studied till now is O levels. So now we'll start from the A levels part. Standard enthalpy changes, standard conditions. So what are the standard conditions? The standard conditions is our reaction has to 110 to the power 5 hobe. There's a mistake. 10 to the power 5
Very
pascals.
pressure.
10 to the power 5 pascals or 1 atm. So 1 atm is 101.325 kilopascals. So we just take it as 1 atm is 101 kilopascals. So how do we know it's 10 to the power 5 pascals? Karan, if you take it as pascals, so it's 101 into 10 to the power 3 pascals. And if you move it 2 decimal places, then it's going to be 101 into 10 to the power 5 pascals. So 1 atm is equal to 1.01 into 10 to the power 5 pascals. You can write this conversion if you want. A temperature of 298 kelvins. So ekhane temperature is not very important. Why? Dekho. Normally, we measure the enthalpy change. Normally, we measure the enthalpy change. Okay. Achha. So 25 degrees centigrade has changed into 45 degrees centigrade. So what is our change? What is our change?
20 degrees.
20.
Okay, now let's convert it into Kelvin. 295 Kelvin is 298 Kelvin. Sorry, 25 degrees centigrade is 298 Kelvin. And 45 degrees centigrade is
Plus 20.
318 kelvins.
18.
So again, if you see the change is still 20. So ekhane enthalpy change is basically we are taking the temperature change. So whether you take the temperature change in the Celsius scale or you take it in the Kelvin scale, it's always the same. So it doesn't matter basically. So, but remember in chapter 5, that formula PV equals to nRT. There, the temperature should always be taken in Kelvin. Why? Because we are not measuring the change. We are basically measuring the temperature. We are you taking the units, everything in SI units. So there you have to use it in Kelvin. But here, it's enthalpy change. Whatever we are trying to find out is the change in energy. So it doesn't matter whether you take it in the Kelvin scale or in the degree centigrade scale. Now, the most important part of this chapter are the definitions. If you don't understand these definitions, you will never be able to do the Hess's law. Our A chapter সবচেয়ে most important thing is Hess's law and the most difficult. So if you listen to me very carefully, hopefully I'll be able to make you understand. So listen to these definitions, okay? Don't just try to memorize the definition. If you don't understand the definition, there will be no point in memorizing it. You can never do the Hess's law. Shuno. Enthalpy change of reaction. Easy. It's the energy change when reactants react. When the reactants react to give us products. For example, magnesium plus hydrochloric acid reacts to give us magnesium chloride plus hydrogen. what is happening here? The reactants are reacting to give us products. There's an energy change. This energy change is enthalpy of reaction. Simple. This is the most simple definition. The equation that describes a reaction must be given. So enthalpy of reaction is the enthalpy change when the amounts of reactants shown in the equation react to give products under standard conditions. What is standard conditions? It has to have a pressure of 1 atm. It has to have a temperature of 298 Kelvin or 25 degrees centigrade. And most importantly, they have to be in their standard state at room temperature and pressure. So, example, sodium normally, magnesium normally তোমাদের কি state এ থাকে in the room temperature? What state is it in?
Solid.
Solid. And hydrochloric acid?
Liquid.
Liquid.
এই জীবনও liquid হয়, aqueous.
Aqueous.
Magnesium chloride?
Sir, solid.
Aqueous.
Uh,
Hydrogen?
Yes.
yes.
So we can consider this to be a enthalpy change of reaction. Why? Because these are all under standard states. But তুমি ধরো যে magnesiumটাকে you have taken in gaseous state, and then HCl was in aqueous state, and then you got magnesium chloride, which was again in aqueous state, and then you got hydrogen, which was in gaseous state. So magnesium in its gaseous state, is it under standard conditions?
No, sir. No, sir.
So this will not be considered a standard enthalpy reaction. Formation. এই দুইটা জিনিস হলো সবচেয়ে কনফিউজিং, বাট এই দুইটা জিনিসই মোস্টলি আসে. What is formation and what is combustion? So I'll just write down two things. Carbon plus oxygen gives us carbon dioxide. Hydrogen plus oxygen gives us water. Okay, sir. Okay. Now listen. Carbon reacts with oxygen to give us carbon dioxide, right? How many moles of carbon are we taking?
1.
Okay. How many moles of carbon dioxide is being formed?
1. 1.
1.
So enthalpy change of combustion is basically when 1 mole of any substance, reacts with an excess of oxygen under standard condition. So can we say that this is enthalpy of combustion of carbon
Yes, sir.
according to this definition?
Yes, sir.
What is combustion? Anything. Suppose তুমি ধরো যে you have taken sodium, you have burned it with excess oxygen, and it gave us sodium oxide. ঠিক আছে স্যার? আচ্ছা. So 2 moles of sodium reacts with oxygen to give us sodium oxide. 2 হবে, এখানে 4 হবে. So can we say that this is enthalpy change of combustion of sodium?
No, sir.
Sir.
No. Why not?
Sir, because we have taken 4 moles of sodium.
The ratio same.
Ratio same মানে?
Sir, sodium और जो compound product है, their molar ratio तो different.
Where did molar ratio come from? This will not be considered as enthalpy change of combustion. Why? Because enthalpy change of combustion defines it as when 1 mole of a substance burns in excess oxygen to give us products under standard condition. CH4. Can we call this enthalpy change of combustion of carbon?
No, sir.
Why not?
It's not burning in excess of oxygen.
Very good, because it's not burning in excess of oxygen, it's burning in hydrogen. So will the is the definition still true? No. The definition states that combustion, if we need to measure the enthalpy change of combustion, it needs to burn in excess oxygen. Every word in this definition has an importance. Right? Okay. Now, next is, let's again take carbon plus oxygen, giving us carbon dioxide. Can we call this enthalpy change of formation of carbon dioxide?
Yes.
Yes, sir.
We can, because enthalpy change of formation means reactant jai hok na keno, doesn't matter. You're not concerned with the reactants. What are you concerned with? You're concerned with the product. When 1 mole of a product is formed from its constituent elements under standard condition. So if we go back to an example like this, carbon plus 3 hydrogen is giving us a C2H6 molecule. So what type of reaction is this?
Change of formation.
Enthalpy of formation of what?
C2H6.
Ethane.
Of ethane, C2H6. So here we had 2 moles of carbon, we had 3 moles of hydrogen. It's not up. We do not need to worry about that, because we are not concerned about how many reactants there are. We're concerned about how many products are formed. If there is just 1 mole of a compound which is being formed from its constituent elements under standard conditions, we call it enthalpy change of formation. So S plus O2 gives us SO2. What reaction is this?
Combustion and formation.
Question.
Sir, both.
Both. We can call this enthalpy of combustion of what?
Sulfur
Sulfur.
Sulfur.
Sulfur. And we can also call this enthalpy of formation of
Sulfur dioxide.
dioxide.
So sulfur plus oxygen gives us sulfur dioxide. So we can call this enthalpy of combustion of sulfur. So whenever we are concerned with enthalpy change of combustion, what are we concerned with? We are concerned with the reactant. We have to make sure the reactant is 1 mole. And whenever we are concerned with formation, we have to make sure that 1 mole of the product is formed. Nitrogen plus hydrogen gives us N2H4. What type of a reaction is this?
Enthalpy change of formation.
Formation
Of
of N2H4.
hydrazine or N2H4. So we're concerned with this. The first three definitions: enthalpy change of reaction, enthalpy change of formation, enthalpy change of combustion. These three are required for paper 2 SAQ. আর বাকিগুলো যেগুলো আমরা এখন পড়বো, these are part of A2, but it also comes for your paper 1 MCQs. So neutralization মানে হলো when 1 mole of water is formed, when 1 mole. So when it's about neutralization reaction, we're concerned about 1 mole of water being formed. And when it's solution মানে হলো যে when 1 mole of a substance dissolves in water. So sodium chloride water dissolve করলে কি হয়?
Aqueous solution form.
Aqueous solution forms of what? It's dissociated ions, right? Right?
Yes, sir.
So
Right.
sodium chloride, the amount of energy released or absorbed when 1 mole of an ionic solid dissolves in sufficient water to form a very dilute solution. Eta A2. A2 first chapter deals with these things, so আমরা will study that later, A2 তে. But আপাতত তোমাদের মনে রাখতে হবে যে when 1 mole of an ionic compound dissolves in water, we call it enthalpy change of solution. And এখানে দেখো there is a wording, energy absorbed or released. তার মানে it could either be an endothermic process or it could be an exothermic process. Atomization is basically when
All right.
you convert it into a gaseous atom. So solid sodium is converted into gaseous sodium. So what do we call this? We call this enthalpy of atomization of sodium. Enthalpy of hydration. এটা দরকার নেই. You don't need this. Instead of a metal, if you take a non-metal, for example, oxygen, then what will oxygen, its gas itself, then what will be the atomization of oxygen? Half O2 becomes O gas. So atomization is 1 mole of gaseous atom is from its constituent element under standard conditions.